It seems that there are innumerable miracles in our solar system. No matter what the theme is, there is always a new discovery. Hello guys! For example, Miranda seems to be a common satellite of the giant Uranus. But why is Miranda compared to Frankenstein's monster? Miranda's formation took billions of years. But what was the reason for that? And what images of Voyager 2, received 37 years ago, transmitted to us? Welcome to our channel. In this video we will talk about all this and much more. Let's start. How was Miranda discovered? So far, about 30 Uranus satellites have been found, but only 5 of them are significantly large. The first of them was discovered by none other than the great William Herschel, also a discoverer of Uranus. This happened 6 years after the discovery of Uranus, in 1787. The protagonist of this video is the 5th largest discovered satellite. It was found thanks to the efforts of Gerard Kuiper in 1948. At the time, following an established convention, this satellite was named in honor of the character of Shakespeare's play. The name comes from the Duchess who appears in the play Storm. It is the smallest of the great satellites of Uranus and the closest to the planet. It has an intermediate form between a small, typical celestial body, like a round stone, and a normal sphere. Due to this irregular shape, it is not possible to express the radius or diameter of Miranda with a single number. The average radius of this satellite varies from about 235 to 236 kilometers. And the orbital radius is approximately 129,000 kilometers. It takes about a day and a half to complete an orbit around Uranus. Similar to most satellites, Miranda also always shows the same face towards the planet. In addition, Miranda's rotation period coincides with the period of orbit of Uranus. Among the satellites of Uranus, Miranda has the lowest density. Its density is equivalent to that of ice, which leads to believe that Miranda is mainly composed of ice. However, there are also small amounts of inorganic substances, such as methane and ammonia, characteristics of the coldest areas of the solar system. Apparently, the ice that brought it all together played an important role in the formation of Miranda. But no, we're not going to rush yet. Miranda can be divided into several parts. Miranda has a mantle with a thickness of up to 135 kilometers, and its center must have an ice or silicate core with about 100 kilometers of radius. Due to the heat exchange that occurs in the interior of Miranda, the formation of the structural characteristic known as corona occurs on its planetary surface. These are unique structures that resemble craters, but are different from them. Curiously, according to recent discoveries, the formation of coronas is geologically very recent, occurring only in the last 200 to 300 million years. In other words, it seems that Miranda's formation took the longest time compared to other celestial bodies in the solar system. Since its birth, most of its existence has been dedicated to its formation. As you probably already know, the way Uranus orbits the Sun is different from the others. It's lying on its side. Miranda, however, like the other great Uranus satellites, revolves around the ecliptic plane, that is, at an almost perpendicular angle to Uranus's orbital plane. As a result, the sunlight alternately hits Miranda's opposite poles. This phenomenon is also observed on the planet Uranus itself. Voyager 2. So far, the only space probe to visit the region of Uranus in history was Voyager 2. Among Uranus's satellites, the closest to Voyager 2 was Miranda, at the end of January 1986. Due to Uranus's rotation characteristics and its satellites, during this passage the sunlight illuminated only the southern hemisphere of Miranda, and Voyager 2 was only able to capture images of this region. In the end, Voyager 2 managed to photograph about 40% of Miranda's surface. Therefore, the regions near the North Pole and the equator remain unknown to this day. These are so far the first and last real images of Miranda. However, these photos resulted in significant scientific advances. Scientists were amazed at the surface of the object, something that was not found anywhere else in the solar system. Their expectations were as follows. Perhaps there are only common characteristics on the surface of the satellite, such as craters, mountain chains, and traces of ancient mantle eruptions. However, these expectations were surprised. Miranda's surface was full of unique characteristics. It looked like a patchwork with several characteristics of different celestial bodies sewn together. In general, Miranda's investigated surface is extremely chaotic. Here there are ancient, dark plains covered by craters created by meteorites, the type of lunar landscape that everyone imagines. These characteristics have existed for billions of years. However, passed through this plain, there are a series of slits formed by light and dark mountain chains, whose origin is a complete mystery. These slits are intertwined, forming something like a spider web. Finally, the roughness of these mountain chains gradually decreases, leading to vast plains. And of course, there are countless craters, valleys, and fissures. Miranda has the crown of winters in its south pole, the crown of Arden in the southern hemisphere in the direction of the orbit, and the crown of Elsinore in the opposite hemisphere. These crowns are probably ring formations created by cracks in Miranda's crust, as mentioned above, but they have completely different shapes. First, the surface of the crown of Arden seems to be a complex mosaic of light and dark areas. Elsinore is an area covered by depressions and cracks, but these characteristics are close to each other. Inverness has a more trapezoidal shape than circular. What marks the border between Inverness and other parts of the surface of Miranda is a complex system of faults with 3 sides. In this area there are numerous lands in tracts and mountain chains. These characteristics and the limits of the crowns draw complex polygons. In addition, when observing the surface of Miranda, characteristics in the shape of a V stand out, surrounded by mountains, valleys, and complex systems of faults. In the center of this area is the large and deep crater called Alonso. The crater is no less than 24 kilometers deep. Miranda's craters are also particularly interesting. There are numerous craters of various sizes in the place, but they are not actually complex concentric structures, which are usually formed by strong impacts of meteorites. The presence of eruption characteristics is rare, and sometimes its albedo is similar to that of the surrounding surface. And this is not common among other celestial bodies. This singularity suggests that these characteristics were formed under extraordinary conditions. In short, Miranda's surface looks like a pattern that someone could see through a capricious kaleidoscope. The contrast between the areas of old and smooth terrain and the parts are chopped with various geological shapes is particularly captivating. In fact, the theory that Miranda was formed by the agglutination of several celestial bodies emerged from this. However, there are other theories as well. Why is Miranda like this? According to the theory of Frankenstein's space monster, Miranda is the result of the collision of several celestial bodies. These bodies collided, fragmented, and somehow intertwined in a chaotic way. In fact, this theory has a flaw. If it were true, then all the planets and large satellites in the solar system, which were formed from the agglutination of small asteroids, would look like monsters, similar to Miranda. However, we do not see any other celestial body with a surface similar to Miranda. What is striking is the great variation in the antiquity of the different parts of Miranda's surface, which vary from a few billion years to just a few million years. The reason why the formation of the surface extended for so long cannot be explained only by the interaction between Miranda's interior and the asteroids and meteorites that hit it. Instead, it may be due to the constant influence of Uranus's gravity, but this explanation is insufficient. Another theory suggests that Miranda initially formed like the other satellites, but then it was shattered by a collision, and later the wreckage reunited again. However, in this case, how were the ancient characteristics preserved? The ancient geological characteristics must have been submerged by ice volcanoes under the surface of this satellite. An additional theory suggests that Uranus may have had another ring, composed of several elements at some point. When Uranus was inclined by a collision with another celestial body, this body disturbed the movement of Uranus's rings. From this point, the gradual crystallization may have led to the formation of Miranda. And with that, we end our video today. Thank you all for watching until the end. And if you liked this video, we will be really happy. In short, there are many theories. However, until the day we can investigate the entire surface of Miranda and bring samples from the soil there, none of these theories can be proven. And this is still far from happening. May this day come soon. Come back soon so you don't miss the next interesting stories here on our channel. And for now, I'm saying goodbye here for a short period. A big hug and see you soon here on the Wikivedia Plus channel. Until then, bye.